Welcome back, guys. Today we have a high yield physics question for the MCAT, and in today's question we are given a large open cylindrical tank and it's filled with water to a height of 10 meters above a small hole on the side of the tank. We're also told that the tank is open to the atmosphere and that the cross-sectional area of the tank is much larger than the area of the hole. What is the speed of the water as it exits the hole? So this is super high yield. We're going to use Bernoulli's equation here, right? So if you see a problem like this, write down Bernoulli's equation, right? And so we have P1 plus rho GH plus 1/2 rho times velocity squared equals P2 plus rho GH plus 1/2 rho times velocity squared on the other side, right? And we have these two sides of the equation and we're going to set them equal to each other, right? Because what we're going to do is we're going to call the left side of the equation the top of the tank, and we're going to call the right side of the equation the hole. Okay? Now we can do a ton of canceling out here, right? So we can cancel out P1 and P2, and the reason we can do this is these represent the atmospheric pressure, right? And so the top of this tank and the hole are both exposed to the same atmospheric pressure, right? So we don't need to put that in our equation if they're the same, so we go ahead and cancel them out. The next thing we can cancel out, right, we have the water sitting here at the top of this tank, and what we're going to say is that the velocity at the top of the tank compared to the water that's shooting pretty fast out of this hole is 0. So we're going to call this 0 meters per second, and so that way we can cancel out this entire term, right? Because we see the velocity here for the top of our tank. If we make that 0, it doesn't matter what the other terms are, it's going to cancel out to 0 when we multiply. Okay? Another thing we can cancel out here, we can actually cancel out this entire term over here, and the reason being is we're going to call the hole 0 meters, and then we're going to measure upwards from there, right? So we're going to call this 0 meters, right? That is the hole, okay? So if we use our height term right here and we call it 0, right? If we plug in 0 for that, we're going to cancel that out, right? And now we're left with only rho GH equals 1/2 rho times velocity squared, right? So we've canceled out the atmospheric pressures, we canceled out the velocity of 0 for the top of the tank, and we also said the height of the hole is 0 meters. When we cancel that out, we're left with this. The last thing we can cancel out here is rho. So rho is a fancy way of saying density, right? And the density, or rho, for our liquid, in this case water, is going to be the same on both sides. So don't waste your time calculating this all out. It's going to be the same, so just cancel it out, right? And so now you're just left with GH equals 1/2 times velocity squared. And so the gravitational acceleration constant, right, is 10 meters per second squared times 10 meters equals 1/2 velocity squared. So this is 100 equals 1/2 times velocity squared, which gives us 200 equals velocity squared, and we take the square root of that, right? We have the square root of 200 is equal to the velocity. Now on the MCAT you don't get a calculator, so what I would do here is do something like the square root of 100 times the square root of 2, right? The square root of 100 times the square root of 2 is the same thing as the square root of 200. This is 10 times the square root of 2, which is about 1.4. So 10 times 1.4 is about 14, right? The answers won't be that similar and that like you're doing the math and that you can't figure it out. So the correct answer here is A, 14.14 meters per second. Make sure you know how to do this, right? Make sure you know how to write down Bernoulli's law and cancel out all these terms and get the correct answer.